So this is question 10 from Chem 1 Stoichiometry. So question 10 says something like this. Anthraquinone, which is C14H8O2, which is used in the dye industry, is produced from the reaction of benzene, which is C6H6, with phthalic anhydride, which is C8H4O3. When those two are reacted, they make this anthraquinone plus water. And the first part of the question says, what mass of benzene reacts completely with 2.0 times 10 to the 3 grams of phthalic anhydride? So 2,000 grams. And part B says that what masses of the products is produced assuming 100% yield. So those are the two products, anthraquinone and water. And then part C says if 1.96 times 10 to the 3 grams of anthraquinone is actually obtained, what is the percent yield? Okay, so this is a three-parter, and you have to do all three parts to get to C. So let's look at how we might solve that problem. Okay, so let's write down this problem. So we have a chemical reaction then, C6H6 plus C8H4O3 and we produce C14H8O2 plus H2O. Before we begin then, let's write down the atomic masses and the molar masses of these three compounds which are involved. So we have carbon, hydrogen, and oxygen. So it's 12.01, hydrogen is 1.01, and oxygen is 16.00. And we'll use those numbers for our when we do our problem. So question A is what mass of benzene reacts with 2,000 grams of C8H4O3? So we got 2,000 grams. It actually says 2.00 times 10 to the third grams, but that's the same as 2,000 grams. So we have 2,000 grams of C8H4O3. And we want to know how much of this reacts, how much benzene reacts with this. And so what we need to do is we need to find out the number of moles. So we just take this and we figure out what the molar mass is, and we find out how many moles we have. So to do that, we then take 12.01 times 8, which is 96.08. We take 1.01, this is for carbon, this is for hydrogen, 4, which is 4.04, and then we take 16.00 times 3, which is equal to 48.00. That's for oxygen. So the mass is 148.12 grams per mole of phthalic anhydride. Then we move these over. So we have 2,000 grams of C8H4O3 divided by the molar mass, 148.12 for 1 mole. Turns out it's 13.5 moles. when we have the 13.5 moles of the phthalic anhydride, we then need to go up to the molar ratio between phthalic anhydride and benzene. And if we look at this chemical reaction, we see that the molar ratio is actually 1 to 1 to 1. This reaction is already balanced. Then we can check that real quick by looking at the carbons. 6 plus 8 is 14. And then we look at the oxygens, and that should be enough. So here we have oxygens, we have 3. There we have 1, 2, 3. And that should be good enough for us to see that the rest of it is balanced. Okay, so now we need a molar ratio, and the molar ratio is, molar ratio is 1 mole of C6H6 to 1 mole of C8H4O3, which is what we just calculated. So if we have 13.5 moles of this stuff, then because it's 1 to 1, we have 13.5 moles of this stuff. And then we can calculate using that 13.5 mole C6H6 times the molar mass, which we can calculate over here, which is then for C6H6, the molar mass is 12.01 times 6, which is 72.06, plus 1.01 times 6, which is 6.06, for a total of 78.12 grams. So 13.5 moles times 78.12 grams, divide by the moles of C6H6 so that we can cancel our units. We get 1,054.62 grams, or 1.05 times 10 to the third grams, if you want to use the same notation as in the question. So that's part A. Yay! Part A! So, okay, for part B then, we have to use the information from part A. So let's write it up here. Then we have 13.5 moles of benzene. Or, well, we figured out that we had 13.5 moles of C8H4O3, which is phthalic anhydride. All anhydrides are nasty stuff. But, so then we have that, and then we reacted it, and we had 13.5 moles of benzene. So now the question is how much anthraquinone did we make with these two things? So since the balanced chemical reaction C6H6, will remind you again, I know it gets a little bit repetitive, but we'll just write it again so that we can see it clearly here. All right, C14H8O2 plus H2O. The ratio is 1 to 1 to 1 to 1. So the expectation is that we have 13.5 moles of this, 13.5 moles of this, and it'll give 13.5 moles of this, and we'll also produce 13.5 moles of water. Great. So now the question B asks for the masses of the two products. And we should just be able to calculate that using our molar masses. Let's remind ourselves, carbon is 12.01, hydrogen is 1.01, and oxygen is 16.00. So, if we just do the calculations then for the anthraquinone, we have C14H8O2. We find the molar mass, it's 12.01 times 14, which is, I'll do that calculation in just a minute. And then we have 1.01 times 8, and then we have 16.00 times 2. And that should be then our molar masses. So 12 times 14 is 168.14. And 8 times 101.01 is 8.08. And 16 times 2 is 32.00. Giving us a grand total of a mass of 208 grams per mole, approximately. Taking our value here then, 13.5 moles of C14H8O2, and multiplying it by the molar mass, 1 mole C14H8O2. The moles cancel, so we multiply it by the grams, and that gives us a value of 2,808 grams of anthraquinone. That's our theoretical yield, if we have 100%, if everything works out. Then the second product, water, is going to be, we'll find the molar mass first, and it's 2 times 1.01, and then of course oxygen is 1 times 16.00. So this becomes 2.02 plus 16.00, which is 18.02. If we take that value and multiply it, 13.5 moles from here times 18.02 over 1 mole of H2O grams equals 243.27 grams, or just 243 grams as our product. So there are our two theoretical yields for the two products of this chemical reaction if we start with 2,000 grams of phthalic anhydride from the beginning and we react it with enough benzene. Now part C of the question says, well, what if we only make, what if only 1.96 times 10 to the third grams is actually produced? Right, of anthraquinone. Okay, so we didn't make enough. It's quite typical for organic reactions that they don't go to completion, or you don't get 100% yield. So then you have to calculate what the theoretical, you compare the theoretical yield with what you actually got, and then you get your percent yield. So what do we actually get? Well, we got, if we convert this, then this is 1,960 grams. And from part B of the question, from part B, right, we get the theoretical yield. The theoretical yield, right? If everything goes according to plan, this is what you should get. 2,800 grams. So to calculate the percent yield, then you take the actual yield, which is given to you by the question, 1,960 grams, and divide by 2,800 grams, and you multiply it by 100 because it's a percent. You don't want a frequency or a proportion, and then you get 70%. So this chemical reaction is 70% efficient, which is